Alright, today we are going to be starting with the quadratics video project. The first thing we'll be doing is finding the maximum using quadratic expressions. These are the first examples that I'll be using to teach you how to find the maximum. So in a quadratic expression, in standard form, it is y equals a variable number x squared plus another x to the power of 1 with a possible coefficient in front of it, plus a random number, and that random number might be there or might not. So in this problem, to find the maximum, you're going to see the variable x squared with whichever coefficient it has in the front of it. So in this particular equation, the maximum value will be 8x squared, and then in the second, it'll be x squared. So when finding maximum value, you're comparing these two equations and you're seeing which one's coefficient is higher. So in this particular example, y equals 8x squared plus x plus 7 is going to be the equation with the higher maximum. Alright, now I want you to pause the video and practice this problem, seeing which equation has the higher maximum value. Alright, now you're back. Now you're going to see that in this first equation, it is no longer in standard form. So it is y minus 4x squared, so we need to add a 4x squared on both sides to make it equal. So your resulting equation will be y equals 4x squared plus 4x plus 8. Wow, it's really hard to write on this. Alright, so now you're going to look again at your maximum value. In the first equation, it's 4x plus 2, or 4x squared, and then 2x squared in this one. You'll be seeing that this problem, the first equation, has the higher maximum, so that is going to be your answer. Alright, the next thing we're going to be doing is creating an expression based off of real-life examples, or better known as word problems. So this is your first example. You're going to read it and it says, Jimmy starts out with $25 from chores. So the key word in this sentence is starts out with. So you know that's going to be one set number. So you're going to write 25 in your equation. And now you look and it says, and is now earning $7.65 a day. So a day shows you that it's going to be a variable with an x next to it. So you're going to do plus 765x. So, and you know that this is going to be a variable because it says here, how many will Jimmy have after a variable amount of days. So the x is going to be the random amount of days to find out how much money he will have after that many days working. So 765 is how much he's making per day, x is the amount of days that he is working, and 25 is the money that he starts out with from chores. So that'll just be equals y, or f of x. Now I want you to pause the video and work on this practice problem and tell me your answer, and then we'll work through it together. So go ahead and pause the video. Alright, we're back. And it says, Christy is trying to find out how much money she will be making at her new sales job. Each week she has a set salary of $400. So in that sentence, set salary, so that of $400. So you know that is going to be one of your main variables. Or not a variable, that's going to be a set number. And then plus commission. Per each insurance plan she sells, so per and each, that tells you that there's going to be a variable number, and the next number available is 65 because we've already used the 400. So you're going to do plus 65x equals y, or f of x if you prefer, and that's going to be how much money she will be making at her new sales job. So the 400 represents her set salary, the 65 represents how much money she makes per insurance plan, and the x represents how many insurance plans she sells. Alright, go ahead and pause the video and give this one a try. Alright, Lizzie is raising money for an upcoming school trip to Universal Studios. She's putting on a school play to fundraise. The cost of the school play is going to be $200 to put on. So 200, that is your first set value. So you're going to do 200. And this equation is going to be a little different. So it's almost more like an inequality. Each ticket entry costs $7, so each is going to be the key word in this sentence. So each will be $7, so you know that's going to be the variable, the coefficient for the variable. How many tickets will she have to sell to begin making a profit? All right, so you're going to already say that she has 200 that she has to pay to put the school play on. She needs to make a certain amount of tickets to be able to pay for the original $200 the play will cost, and then she will start making a profit. So you're going to have an understood dollar sign here almost, and so the $7 will go here with the X, and the X will be how many tickets she has to sell, and the 7 is the price of each ticket. So you want to see how long it'll take to get how many tickets it will take to get to be able to start making a profit. So that is your equation for that.
Okay, now we're going to talk about graphing quadratics. When you graph a quadratic, it ends up being a curvy line called a parabola. You can recognize a quadratic equation from a linear equation when the variable you're working with is squared. As you can see here, in a linear equation, the variable x is not squared. And in a quadratic equation, the variable x is squared. Being squared, it causes it not to have a constant rate of change or a slope, which makes it a curvy line when you graph it. What are parabolas? Parabolas are shaped like an arc. All parabolas have either a minimum or a maximum value. The minimum value being the lowest point and the maximum value being the highest point. A parabola cannot have both minimum and maximum value. It's just not possible. Okay, now here, for example, when you kick a soccer ball, it arcs up into the air, it reaches a maximum point, and then it'll come back down. Okay, now I want you to graph this parabola. Okay. What you should have done when you graphed, it should have been like this, it should look like this. And notice that the y-intercept is 4, and your minimum value should have been -2, 0. Okay, now we're gonna solve by completing the square. What do you have to do when you're completing the square? My bad. What you have to do when you're completing the square? First, you must have the second variable constant, and then square the result. So you must have this right here. So it'll be 5, and then you square that, so it'll be 25. And then you add 25 to both sides, as shown here. Okay, then factor and combine like terms. So you have to factor this right here, and then it would turn to x -5, and then add 16, 25, and it'll be 41. Oh, x -5 squared. Okay, once you have combined like terms, you can put the equation into standard form by passing this number right here to the other side of the equation. And then once you put it in standard form, you can use the equation to graph, or you could just graph the equation and find the intercepts and minimum or maximum value. Okay, so here I have 2 problems that I would like for you to practice. So pause the video here. Alright, what you have done for the first problem is this graph right here, with the intercepts being y negative 25, x equals 5, and x negative 5. And the minimum value should have been 0, negative 25, all the way down here. And then for this problem, you should have gotten x negative 3, or x minus 3 squared minus 2 equals 0. I missed a 0, but that's what you should have gotten. Well, thank you for watching this video. I hope you enjoyed.